Welcome back to Functional Anatomy. We will be looking at major joints and their actions in this video. Now, you have studied the skeletal system and the muscular system, which together forms the musculoskeletal system. The joints are formed at the point of attachment of the bones. Now, joints can enable movement or can form relatively closed and rigid structures, like the joints in the cranial bones, whereas the ones that allow movement are all across our body. So here is a cross-section of the human body, the sections you saw in anatomy, where there are multiple bones which are connected together. For example, here, 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 every single where in this section, right? Every single location here. There are joints here. If you pay close attention to this section, there are multiple bones that are joined together, right? There are joints everywhere between those 206 bones that are found in the human body. Now, from a movement science perspective, we will only look at the joints which are responsible for the main movement of the body involved in daily activities or sports activities. Okay. So we will progress from the top. We will look at the first joint at the top, which is the neck joint. Then we look at the shoulder, the elbow, the wrist joint, the hip joint, the knee joint, and the ankle joint. Most of the joints that we will look at will be what are called synovial joints, which have a synovial cavity in between the interface between those two bones that are 2 or 3 bones which are moving, and a synovial fluid is filled inside this cavity which lubricates the joint and allows for efficient movement. So let us start with the neck joint, which is also called the cervical spine. The neck joint is comprised of 7 vertebrae from C1 to C7. Okay. So this is the rear view where you're looking at the vertebral column. And in this case, the first vertebra is also called atlas, and the second vertebra, C2, is called axis. The reason this is called atlas is coincidentally the related to Greek mythology, where Atlas is hoisting the entire world on his shoulder, and hence the entire world being the brain and everything that houses the brain. Right. So atlas is ring-shaped bone at the base of the skull. So this is where the skull interfaces with the vertebral column, and axis allows the atlas to pivot. So it can pivot in this plane. This entire thing is surrounded by muscles, right? The nerves that innervate these muscles, the spinal cord that goes down here, and there are intervertebral discs in between each of these vertebrae. This entire thing forms what is called as the neck joint. Okay. So there's no single joint. It behaves as a compound complex joint because of the articulation of all these vertebral columns on top of each other, controlled by the muscles. So now let us look at the actions that can be performed by the neck. And all of this will be very intuitive, very understandable. We'll just provide a language and terminology to most of the movements that you're already familiar with. So first off, is flexion and extension of the neck. So the neck allows for the head to tilt forward and backward in the sagittal plane. This is an important movement for looking up, looking down, protecting yourselves during a martial arts movement, for example, right, for nodding. So this is one of the common movements. So the entire stack of vertebrae controlled by the musculature allows for the entire neck to rotate all the way around. So next up is lateral flexion, and that is the side to side movement of the neck, which allows the head to move towards the shoulder. This movement is in the frontal plane about the sagittal axis. Finally, the last thing I would like to talk about is the role of neck in providing stability and support. Now these are, since we said that the neck is made of 7 blocks, or the cervical vertebrae aligned in sequence, and they are dynamically stabilized by these muscles and ligaments. One of the key functions of the neck on a day-to-day basis is to keep the head upright and allow us to interpret the world, right? With weakening of the neck muscles, for example, you can have a slack posture where the neck can go down, and that can lead to a very different interaction with the world in terms of load-bearing capabilities or even how we perceive the world. All right, so we have looked at the neck joint. Let us now move to the shoulder joint. The shoulder joint, also known semantically as the glenohumeral joint, is a synovial joint, which means there is a synovial cavity here which holds the liquid that lubricates this joint and provides a lot of mobility. In fact, the shoulder joint is a ball and socket joint, and it is the most mobile joint in the entire human body. Okay. It attaches the upper limb, which is this arm, to the axial skeleton. So that's the head of the humerus, which attaches to the skeleton here, the axial skeleton. So because it is a very mobile joint, it is primarily only dynamically stable. So it has sacrificed mobility for stability, which is to say that to hold a particular position without the help of muscles, this would just act under the external forces acting on the segment, right? So if there were no muscles, or the muscles were rendered immobile in this condition, the limb would just slacken down to my side. That means that the muscles that surround this entire joint, the shoulder joint, are playing some of the most crucial roles in mobility, stabilizing and controlling the movement of the joint. Okay, so let's see what kinds of movements this joint can do. Okay, so the first is flexion and extension, right? So flexion is moving in the sagittal plane, right? So if I am moving my shoulder forward and backward, like so, as I'm doing here. So right now, at this very instance, this is flexion, right? And this is the extension movement as seen from the side, right? So from the side, this is the sagittal plane. So from the side, this is the sagittal plane, and the extension movement and the flexion movement, which will happen right now, is happening in the sagittal plane. Okay. Next up is the movement in the frontal plane, which is the abduction and adduction of the shoulder joint. So abduction is the movement away from the body, and adduction is the movement towards the center line of the body. Okay, This is a very important movement. You do this in exercises for the shoulder joint to strengthen these muscles. You also do these movements for a lot of sports activities and on a daily basis when you're trying to manipulate objects in your environment. Say, reach sideways onto an overhead object. Okay. Okay, next up you have internal and external rotation. So looking at the movement from the side, movement in this direction is external, and movement towards the body, front of the body, is internal. So what is actually happening here is, if you were to run an axis along the humerus, for example, right here, it's the rotation about this axis of the shoulder joint, right? So a very different set of muscles is involved in this activity compared to, say, flexion and extension, right? Or I should rephrase that. The same set of muscles are acting in a very different way when there is internal and external rotation. And finally, you have horizontal abduction and adduction. So abduction is this movement away from the body, and adduction is this movement towards the front of the body. So elbow is the joint between the arm and the forearm, which is the arm and the forearm. So this is the humerus bone, very funny, and this is the radius and ulna. Okay, and this you have already studied in the skeletal system. Again, this is a synovial joint, and it is separated by a cartilage layer. A fibrous capsule encloses this joint. Okay, and this is primarily a hinge joint. And I'll qualify this statement that it is primarily a hinge joint. Okay, so when I think about elbows, the first thing that comes to my mind is a bicep curl of some sort, right? So I'm looking at this movement. This could be in this plane, it could be in this plane, right? It could be out here. But with regards to the humerus, the relative position of the radius and ulna are not changing significantly. Okay, so this is acting as a hinge joint primarily. And because it is acting as a hinge joint, it also limits the range of motion, right? So I cannot move my forearm past a certain point at which there is a hard stop where the bones connect. So if it is primarily a hinge joint, is there something else that the wrist can do? So I invite you to try this out. Try and rotate your palm like so. Okay, and think about what is it that you're actually rotating. Okay. Is it, if you fixed your forearm, for example, and you try to rotate your palm, okay, hold it really tight and try to rotate your palm now. Okay. Okay. So that's the interesting part, that it helps with pronation and supination at the wrist, right? So because there are two bones there, and I'll go back to that figure, because there are two bones here interfacing with the humerus, there is scope for the relative movement of these bones with respect to each other, which allows for the pronation and supination. And you can feel this when you do this movement in your hand. You'll be able to feel the radius and ulna moving relative to the upper arm, to my arm. And that's because the arm is fixed and these are just rotating at this point, right? Okay, we'll go back. And finally, because of the dynamic nature and musculature present here, one of the functions of the elbow joint is to handle the loads during load bearing tasks like pushing or pulling, right? So if I am pushing against a particular load, right, or if I'm pushing against this load here, right, my elbow is supposed to remain in this position and not buckle under the load, and that function is primarily supported by the muscles, right? It is a dynamic stability that I'm trying to achieve here. So that's it about the elbow joints. Now let's take a look at the next joint in the series, the wrist joint. The wrist joint is also known as the radiocarpal joint. It's a joint between the end of the radius, the distal end of the radius, and an articular disc here, and three proximal carpal bones. So these are the carpal bones. So it interfaces with three bones here. And this is also a synovial joint. So what can the wrist do? The wrist can do flexion and extension, right? So if you hold your palm facing forward, you can move this, right? This is flexion and extension, right? Okay. Next up, you can put your palm facing forward and you can abduct or adduct your wrist. So when you're saying hi to someone, that's a combination of abduction and adduction, which are technically referred to as ulnar deviation and radial deviation respectively. And if you combine all of these, you can get a circumduction or a rotational motion possible. Okay. And again, I want to emphasize here that the wrist cannot move along this axis. There's no rotation possible like this, right? It is because of the nature of the radius and ulna and its coupling with the humerus that allows it to do this kind of a rotational motion. But your wrist actually does not. The joint in itself does not rotate. Wonderful. So we have done the upper body. Now let's move on to the lower body.